company. We started back 150 years ago in 1874 as a local blacksmith in Blitterswijk. That's why we called Blitta. Blitterswijk is a little place near Venray. We started in the 1970s with aluminum, and we did it in combination with the system house Schuko that you probably might know or not know. We also made steel windows. The first facade engineers made their windows in steel from the 1900s on. We quit with that in the 2000s, in the zeros, because of the thermal properties, and nobody wanted those anymore. So we made a switch to complete aluminium and integrated facade solutions. That means that, yeah, we are doing a little bit more difficult projects than just a simple window or a door. We are more for the complete facade solution. Our revenue on a yearly basis is between the 20 and the 30 million euros. We already got the goal of 30 millions for this year, so it's going up again with the building business. We got about 110 people employed for manufacturing, also the mounting of the facade, engineering, and a little bit of product development or project development. We all do that. So we have our markets in the Netherlands mainly. This time it's mostly Amsterdam, Rotterdam, and Utrecht district, where we see a lot of redevelopment of offices, which are going to be turned around to the 15-minute city states. We do both segments as residential and non-residential. So that means we have to take a very broad approach for the solutions that we have. Every kind of type of segment has its own solutions, do's and do-nots. The added value of us is that we have all the disciplines on one roof. So we do from the pre-sales engineering, that's my job, to engineering, manufacturing, mounting for the complete facade solution. That's not only the facade, but also the cladding and so on and so on. And if we don't have it in-house, we will search a party who is a specialist, and we will co-occupy for the building. Here you have a little few examples of unitized curtain walls. The first one that you see on the left-hand side, that's Hoog Catharijne in Utrecht. You see the entrance, it's a completely curved facade, and we developed a unitized curtain wall system for that. That's quite unique. The other one that you see on the right-hand side is Oku House. That's one of the projects that we visited with GEOPS in the past, about 2 years back, was in 2022. So we're going to make this year also a visit to a building site. So if you want to have some experience how it's going on a building site and see what the do's and do-nots are and experience them yourselves, we're trying to plan it for a project also in Amsterdam. Before I continue with my lecture, perhaps this is already known for most of you, but I shortly will tell you what the unitized curtain wall is. A unitized curtain walls, you make an element that's about story floor high and a certain width, and you hang it upon some anchors. You prefabricate it as much as you can see at the top pictures. The complete element will be hoisted onto place, will be put there, and your wind and air tightness is finished, so you can start with your interior building process. What the thing is, when you are developing your building, you have an interior infill that directs how many space you have, how many houses you can make in it, what the revenue will be, and it has an effect on the facade. And that's what I'm trying to explain today, is you developing a building, you have a facade, you have a kind of a feeling how the building should look, and how do you approach on a cost-effective way so you don't get too many problems that you have to solve afterwards or during the process, and to keep the costs as low as possible to make it an effective cladding. Okay, how do you design a cost-effective element facade? First thing you got to think about is, okay, I got my facade, one big surface, and I have to divide it into elements, and how big is an element, and what is wise, where to put the separation between the elements. I've got here a little example of an unitized curtain wall facade. If you want to look afterwards, I can tell you this is the joint point, and this is a facade element on this side, and a facade element on that side, which is stacked on the starter. The second thing that you have to think about is, okay, I've got a layout for my facade, but is it a wise layout? Are there some things that I can do to make it more cost effective and still reach the image of the facade that I want as an architect or as a builder? And what are the dimensions of one element? What is a directive in which you can take that into your thought process of building your facade in your design? First, I want to approach the element divisions. Here you got a little segment of a quite generic building. And you see horizontally, you see in orange, you see the floor bands, and you see another profile floor band on the second store. Let's see if I can make a pointer. No. That's and with a vertical closed segments. When you're looking at the floors and the walls of your building, you have the floors that you need to build your stores, and you also have constructive walls. Just think in domestic building, you need to have a very solid wall to meet your sound demands, fireproofing demands, and you use them as a constructive part of your building, like a tunnel building or prefabrication concrete building. So if you want to make a division, this would be the most obvious division. You're trying to make it from constructive wall to constructive wall, if possible, and from floor to floor. Why? Because you have your separation with the acoustics that you see in the cross-section that we have with the red arrow. That's the arrow for S-fire proofing. You need 1 hour in Dutch building regulations for domestic housing between one fire compartment and the other fire compartment. Each house is a fire compartment. And you need soundproofing from one point to another point. That's not only domestic, but also for more office building related. Because if we have a secret meeting here and we are all conspirators, we don't want them upstairs to hear what we are discussing. At least I don't. You can see I made a little comparison to timber frame construction. Those rules that I'm telling you today also fit 90% for timber wood constructions, which is an often used building method at the moment. There's only one thing that you need, and that's going to come in the layout. I will explain. Just remind that we put the separation lines here on the center of the floors and the center of the concrete walls that we have. Those have a little impact on the layout. Because if I want to make a layout of this, how do I separate it? Where are my boundaries of my element? And for example, in this facade, we take the black dotted line as an example. And I will show you a few steps how you could approach it. So it's from your visual design to a more practical design. You can see here that the centers of the floor and the centers of the wall are really on the centers, which has the next impact. If I make a division, you see on my left-hand side, you have a very small compartition which is opaque. And at the bottom, you also see a very small compartment which is opaque. What you should try to avoid are small compartments. And why? Every compartment, oh, I'm going too fast. Every compartment is a panel that you have to manufacture. Means handling, means costs. If I make one big panel, it's cheaper than I make 5 small panels with the same surface area. Also, there are connections. You see where the mullions and the transoms are connected. There are many connections in this for the small compartments of the panels. If you can reduce them, you can save cost. Also, the rigidity of the element is better when you have larger compartments. The second thing that you can try is to limit the opaque compartments. Everyone thinks that glass is very expensive. It is. But an opaque panel is, I think, almost twice as expensive, which you do not think at first, but it is. If we try to make an optimization in an architectural design, when we are going to have a discussion with the developer and the architect and the building team, and they want to make to save costs, we always say, okay, try to make the opaque parts a little bit smaller, and in the square area that you have as a result, you can save money. If you have a big building, it goes real fast. Talking about hundreds of thousands of euros, not tens of thousands. When you count here the amount of compartments that I have in this first initial sketch idea, you can see I can count up to 9 compartments. If I reduce the compartments, I make it cheaper because my opaque panels will be bigger. The amount of joints that I have to manufacture and produce are less. And the amount of profiles that I have to use is less. This is my first step for the optimization. I've optimized the top panel, but still I've got on the left-hand side and on the bottom side a smaller panel. So the next step is to make my element layout where I put the divisions to translate them to a more logical place, because now I'm splitting on the middle of the floor and the wall. That means I've got an opaque on the left and an opaque on the right, on the top and on the bottom. So if I want to optimize, I'm going to shift them a little. I'm going to shift my division on floor level, that's the raw floor level, and I'm choosing a side, left or right, and that depends on what's behind the facade, which is a more logical choice. I put it on the side of the wall. When I do that, I'm going from 9 to 5 compartments. So this element is the same surface, the same opaque surface, the same transparent surface, but I think we reduce the costs by a third. So, if you're looking at the details, you can see the horizontal detail that at the right-hand side of the wall, where you see the 2 gray squares, that's where the division is. That's this division. And you can see at the floor level that just below my finished floor, I make the division. I will explain. If my neighbors are shouting or making hard music or playing in a band or whatever, here's a rubber gasket which makes sure that everything that starts vibrating here doesn't communicate through the metal with the underlaying element. So for soundproofing, that's a good point. And also for fire, what you have in a fire start is that at this side of the building, inside the building starts a fire. we put some galvanized steel plates between the floor and the element, and we fill it out with a mineral wool. And that's been proved by many building physics bureaus as fireproof. And we even did an SBI test on such an element, and it should have taken 30 minutes, but it held up for more than an hour. So what's the point if I make him on the middle of the floor? You cannot reach the anchors that you hang it up. This is what we put on the floor, just like this. Then we have a slot here. A slot here where we can put an anchor that we make on the element. And then with this swing, we can adjust it in height. And if it's too low, we cannot reach it anymore. Here we have a bigger picture of the anchor. You can see on the right-hand side, that's the part that we prefabricate on the floor. We love anchor rail, so we don't have to drill, and we have a very tight connection to the floor, which is capable of taking much higher load bearing than when you use a drill anchor or a chemical anchor. It also speeds up the building process, and when you have prefabricated floors, 9 out of 10 times it's not a problem at all to take them in the building process and to make good arrangements about deviations that's allowed in the anchor. We use that 80% or 90% of that we use. On the right-hand side, you see the thing that's perpendicular on the anchor, and that's the part that we bolt on the element, and that's where we hang him on. It's just like a picture frame that we hang. So if you have the anchor on the right spot in the right place, we can do 15 elements a day. If we are lucky and we have a good hoist on the building site crane, we have done many times a complete floor on one day. So you can produce very fast to start with your interior finishing. Let's see, what's the difference between this? Oh yeah, here you can see underneath the anchor where the vertical block is, we use bolts so we can screw them up. So if you have a construction floor and you haven't got the finished floor yet on, but on its own weight, it will bend, and we can compromise for that. So if you load up the floor and you take your finished floor on it, our elements will be level. This is a detail how it looks when we work it out in AutoCAD. You can see the anchors. The difference between the anchor that you see on the picture and this anchor, this is an anchor that we place on top of the floor. But sometimes you don't have only a floor, but you will have a vertical concrete slab as a wall. And then we can use the type of anchor that you see in the AutoCAD picture to put it on the front side of the floor instead of on the top side of the floor. So that's also a possibility. Now we're going to the dimensions of an element. How do you dimension an element? Because unitized curtain wall is just like a Lego brick. And you could imagine what is a good direct state, in a design phase of your building, it's better to take these dimensions, and you can always make an appointment with the one who's going to build the facade in reality what his limits are and which things are important. You can go bigger, but that means that you have to hoist by the building crane on the building site. There are situations where they need them for prefab, to put the prefab concrete slabs and the floors. So you have no crane time, so you have to be self-sufficient. That means that you have to unload from a truck with a truck crane and hoist them onto place, then the dimensions are smaller. Or you put a mini crane on each floor, then your dimensions are smaller than what you can do at the max when you have the building crane. There's another important thing. When you create up an element, where the element stops, you will get a joint in your cladding, no matter if it's MBX concrete, or it's aluminum cladding, or it's a natural stone finish. And you will see now, we made a division here for this example, and these are 3.70 meters wide and 3 meters high, so that's bigger than the design directive I gave you. And we made a division of the compartments visual. And here is how we divide them up. We take one element here, because we went above the 2400 as a directive. And we divided the element into 2 elements per concrete wall that we need to support. Sometimes you have those concrete separating walls, not on 4 meters, but also on 8 meters or 7 meters 20. So it could mean that you divide the element into more divisions, but you always make sure that the start and the finish division is on the left or on the right side of your concrete wall. That's the important thing to know, and how you do it in between, there are a lot of possibilities. And that means also that the division that we made here of the elements will visualize in how your cladding will become. If you're looking at the orange band on the floor level, you can see that where the element is divided is also joint in your cladding. Is that a problem? It could be. That's what you visually want as an architect. But I hope that you get the message that you have to make a division of the element due to size, that it has consequences for your visual lines in your facade. And now you know a little bit where they're coming from. So if I meet you in the future and we have a discussion about a facade, we both know why we did it. Not because we like, but we had to. So that's the thing I think is important to take in mind. So this is the building that I talked about. This is lab 42. And we made an elements with a dimension of 7 meters by 4,300. I said 44, but 4,300 millimeters. Who's good at math? How many square meters is that approximately? About 29 or 30 square meters that you put in one element at a time. So that means very rapid enclosure of your outer skin of your building. This one is even more special. As you can see, we can take them out and put them back in again. That's very special. Normally, a unitized curtain wall is not capable of that, but we devised something special for this project. And it already came in handy because they made an error with the concrete floor. So we had to dismantle a few elements and they report the floor, then we put them back. So this is a little picture of our production facility where you can see that they're making the elements. We want to make everything as prefab as possible. We don't want to do anything on the building side. We just want to take the picture frame, hang it on the right spot, and we're off. That reduces risk. You have the wind and the air risk of the permeability with one party. When we are finished, your interior guys can start and finish it off. So, if you want to design a cost-effective element facade, You have to take care about the element divisions. Look where are your walls and where are your floors to make a logical for sound and fire. So that means you don't have to put in an extra finished cladding in the interior to make it fireproof or add on extra mass to get it more soundproofing, because that's quite expensive if you're taking it over a total of a project. The layout, try to limit the amount of opaque panels, but also the panels overall. It saves you money because you only have to make one panel instead of 5, and it will save you money because you don't have to make all the joints of the mullions and the transoms that you got in the story. The dimensions that you have to remember, divisions of 600, 1200, 2400, and so on, 3600, 7200, etc., etc. And you have to take in account that where you put your joint of the element also will be a joint in your cladding at your floor or at your pennant cladding that you have. Those are the things that you have to take in account. So I hope I gave you a quick guide for anyone who does architecture and is building a facade. Hey, I can do it like that, and perhaps it will go a little quicker, and you still have a cost-effective facade. That was my lecture for today. I hope you enjoyed it and you had something about the directives that I gave you. And I hope I will soon you soon in the future when we're going to a project visit. So, thank you for your time and your attention.
Yes, thank you, Harold. Thank you very much for organizing this lunch lecture for us today. I have a little something for you. I have the gepels and a bottle of wine, of course. For all of you, you can scan your student cards upstairs to get your My Future points. Please bring your cups with you.